Hello everyone, welcome back to our Generative AI from Scratch series. So in the last video, we've started about the transformer and LLMs. So we'll continue with those in this video. And in this video, we'll learn some internal components like multi-head attention, positional encoding, full encoder block, and full decoder block. So multi-head attention, like in the previous lecture, we discussed about the attention mechanism where model provides attention to particular words, okay, to better understand them. But like in a long sentence or in a long paragraph, when we have different words, so how it will work differently. So in that case, single head attention won't work that much better. Okay, so for that we need the multi-head attentions kind of thing. Okay, so for example, we have a sentence: a dog chased the cat in the garden. Now in this sentence, we have different relationship. So we have different relationship that exist in this sentence, like subject verb relation between dog chased, and then verb object between chased cat, and then there is location as well, like garden, and then grammar with the other words like the, in, kind of thing. So for this example, one attention head cannot learn all these at once. So the solution is to use the multiple heads. So by using multiple head, each head will have its own query, key, value matrix that we discussed in previous video, and it will look at the sentence very differently, and it will learn a unique pattern. And then finally, all heads will concatenate and then combine the understanding. So the similar the diagram I'm showing to you, simply we get the input embedding and then we split them into different heads, and then each head will process the unique processing. One for verb, one for object, one for location, one for punctuation. There may be the other as well. So automatically inside the transformer, they automatically split these into different heads, and after the processing is done, they concatenate all heads and then they provide it to the final layer. Now comes the positional encoding. So when the transformer reads any word, it does not read in order like from left or from right side. Okay, so it could basically misinterpret the words as well. Okay, so if we have word cat eat fish, okay, so it is very important that it remembers the position of each word. Okay, which word is first, which word is second and third. Okay, so for that we add a vector to each word embedding representing its position. Okay, by that transformer will be able to when they do the encoding and decoding, they will be able to remember that what word came first and what word came last. Okay, so that is very important. Otherwise, if we do not do that, so what will happen? The sentence is cat eat fish. It may be possible that it will take it in reverse order. By default, it will take that fish come first, then eat come second, and then cat come third. So what it will interpret it as? It will interpret it as fish eat cat, which is logically wrong, which is not possible. Okay, so that's why it's very important. The positioning is very important. So for that, the final input that we provided, we give it the token embedding, its unique token plus its position embedding, on which position that word we provided as an input. Now comes the encoder block, full encoder block, and then we have the full decoder block as well. So these encoder and decoder are very important, and they does some task internally. So like encoder with its name defined, it reads some input, it understands deeply, and then it produces meaning rich representation. Similarly, the decoder block takes encoder's understanding. So basically it takes the encoder's output as an input and uses it to generate the new text, predict next word step by step. So full encoder block, they follow some step, like each word gets a meaning and position, then self-attention, then normalization, then it provides it to the feed network, okay, so which also calls the mini brain of our transformer, and then the normalization again. Okay, so these certain steps they follow. So for example, the cat sat on mat, the example we took earlier as well, the word cat basically looks at the sat on mat and itself. Okay, it asks question like who is doing the action, where is the object, what word help me understand the meaning. Okay, so this is the self-attention mechanism. And then comes the normalization. Okay, when you keep your original writing but also add your corrections to it. Okay, and then comes the feed forwarding layer where there is a mini brain which help your model to go from a raw meaning to a very deeper meaning. And then comes the final encoder block structure. So after the full encoder process, what happens is it gets its meaning, it gets its position, and then how other words relate to it. It has that basically relation with it, and it corrected all the grammatical and semantic things. Okay, and then it has the deeper context as well for that word. So now after the encoder does this whole encoding, it will be able to understand the cat sat on the mat is not equal to the mat sat on the cat. Okay, so it has all those detail, it has all the positioning that yes, this is the position of all the words in the sentence, this should match in the output as well, so it will not get confused between the similar words in the sentences. Now comes the full decoder block, which takes the output of the encoder. So the first step it does is mask self-attention. So what is mask self-attention? Basically, the model should not look at future word. Okay, so future words, let me show you with an example. So in this video, you can see I have this sentence, I love pizza. Okay, so the first I that we have word, it can only look to its previous word or value or itself. Okay, it can either look itself or the previous value or before its position. It cannot look for the value that is ahead of it, like love in this place. And love can look for I and love, but love cannot look into the pizza word. Okay, so we similarly the future words we cannot look. Okay, the previous word cannot look the future word. Now comes the second most important step where the decoder looks on the encoder output that I was talking about. Okay, so it talks or it communicate with the basically with the encoder. Hey encoder, what did you understand from the input sentence? Okay, so for example, if we have this word, I love Spanish, and we ask the model to translate it. So basically, decoder will ask the encoders to explain what is I love Spanish, what is the meaning of this I love and Spanish. Once decoder provides the detail, oh sorry, the encoder provides the detail to the decoder that I love apple means this. So then decoder does its job. Okay, I get the meaning, I get the positioning and all. I know the positioning and the context of this word. Now I can decode it. Okay, so now sorry, now I can translate it. So now the decoder will translate the word and it will do the actual job which is required. And then after that comes the neural network, the feed forward steps, which is same that we had in the encoder step. Okay, and then the final output gets generated after it. So the final work of the decoder does is it does the mask attention, generate one word at a time without cheating, that we understand. It will not look for the future word. Okay, and then cross attention where it use the understanding of the encoder, then it feed forward, which basically refine the meaning, and then it repeats this process until the text is improved, the quality is improved, so it can provide you output. So basically it generates these word by word. So whenever you will see, you have ever noticed when you write something to the ChatGPT, Okay, and it takes some time, it analyzes it, and then it writes the output. So you have noticed it writes everything word by word. Okay, so you must have noticed these things, that it writes these things word by word. So that is done in by the decoder. So that was all about this video. Now I'll see you in the next video where we'll discuss about the more generative AI concept. So till then, bye bye.